that I left on the last class. I was discussing the locus, the concept of locus we were discussing. Today I will solve the problem also. So this is the re-exam date and time, 2077-522, that is tomorrow at 2 p.m. for class 9. Please let me know, okay, if you have not taken online examination, or if you have not, if your friends have not given the online examination, please inform them, okay, so that we can arrange the online examination for specific students only. So let me continue from the slide that I left from the last week. Okay, let me begin from the definition of the slope. Okay, please write, I requested you to write it on the last week. I don't know whether you have written it or not. If you have not written, please write it. Definition of a locus. Locus of a point is a path traced by a moving point under certain geometrical condition. Okay, it is a path traced by a moving point under certain geometrical condition. What does it mean actually? This is the formal definition. What it actually means, I explained it on the last week also, so let me explain it in brief here. Suppose there is any fixed point. Okay, please don't forget to mute your microphone. Suppose there is a fixed point. Let me explain the different examples of locus here. Okay, suppose this is y-axis, y prime, x prime, and this is origin. Suppose you move in such a way that you maintain a fixed distance from x-axis. Okay, suppose this is Mr. A. Suppose this is Mr. A. This Mr. A is moving in such a way that its distance from x-axis is always fixed. Let us suppose it is 3 units. Okay, again it is 3 units here. Again it is 3 units. Okay, it is satisfying certain condition to move such that it traces a path. This path is called the locus. Okay, कुनै एउटा मुभिङ पोइन्ट हुन्छ, त्यो पोइन्ट हिँड्छ, त्यो पोइन्ट हिँड्दाखेरि जस्तो पाथ भन्छ नि, हो त्यो पाथको चाहिँ हामीले इक्वेसन निकाल्ने हो. त्यो पाथ नै त निकाल्ने हैन, हामीले कस्तो पाथ बन्छ भनेर we will not show. We will just find the equation of this path. Okay, these straight lines have name, that is equation. जस्तो कि for example you have name UBS Katual हैन, मान्छेको त स्पेसिफिक नेम हुन्छ नि, so that we can recognize them, so that we can have a picture of them. But the different straight line, they don't have specific names, they have equation. Instead of name, they have equation. The equation x is equals to 3 or the equation y is equals to 3. They have the same name in America also and in Nepal also. Okay, the language of mathematics is same or is universal throughout the world. Okay, so what you need to understand is the equation that we find is the equation of locus here. ओके, जति पनि यो इक्वेसनहरु छ नि, अब हामीले निकाल्ने गर्ने त्यो चाहिँ कुनै एउटा स्ट्रेट लाइनको, कुनै एउटा कम्बिनेसन अफ स्ट्रेट लाइन्स को, that is the equation of locus. Okay, we can take analogy that the name of human being is almost similar to the name of the equation. Sorry, the equation of the straight lines or equation of any curve. हैन, suppose there is a circle. There is a circle of some size here. अब यो circle को equation हुन्छ. This circle has a equation x square plus y square is equals to 9, something like this. Okay, so what you need to be clear is that every equation represents a curve. It's just equation हुन्छ नि, equation भनेको बीचमा यो x र y को रिलेसन हुने, बीचमा equals to हुने, अनि the 0 or something constant, something like that will be there. And if you trace it, then it will be any geometrical figure. So either that may be a straight line, that may be a ellipse, that may be a circle, parabola, hyperbola, a lot of things are there, but it represents certain curve. जति पनि इक्वेसन हुन्छ तिमीले त्यसलाई चाहिँ फिगरमा रिप्रेजेन्ट गर्यो भने that will be certain circle, straight line, त्यस्तो हुँदै जान्छ के. So locus, let's define locus again and let's go to the next slide. Locus of any point or locus of a moving point or locus of a point is the path traced by a moving point under certain geometrical condition. Geometrical condition like अघि मैले भनेको थिएँ नि, x axis बाट जहिले पनि 3 units मेन्टेन गरेर जाने. Okay, The distance between y-axis is fixed always. First geometrical condition are satisfied by the moving point, and the path traced in such condition is the locus. Traced means drawn. Okay, so let's go to the next one. Okay, let me show you how the path. मैले भन्न त भने त्यो यसरी हिँड्दा चाहिँ एउटा path बन्छ भनेर भने. Let me show you how the path is developed. Okay, so let me share my screen again. I have to share my desktop here. Just a minute. Okay, I think this is displayed in your device. So, okay, let's go to what actually this locus means. Let's go to explain it. Okay. So here, this is a coin. Okay, this is inside a circle, and its outer part of the rim of this coin is attached to the inner side of this bigger circle. Okay, I am going to trace the path followed by the center O and the point P. Okay, so here let me move it at first. Okay, this coin is moving inside the circle. Okay, and these 2 points are also moving, isn't it? Since this point P is on the circumference of this coin and this O is at the center, so let's see how the path is traced. Okay, if we only consider the points O and P, how the path will be, how this coin will trace the path. Let's see. Okay, अब यो O र P लाई मात्र हेर्दाखेरि यो पोइन्ट हिँडिरहेछ नि, हेर्दा यसको एउटा फिक्स्ड पोइन्ट हुन्छ नि, यसरी घुम्दा त यो पोइन्ट त यसरी आउँछ, चेन्ज भइरहेछ. Okay, how the path will be fixed here, how the path will be traced here, let's see. Okay, let's see the path of O at first. Here this center O is tracing this path. यो हिँड्दाखेरि जुन मुभिङ पोइन्ट छ नि, यो मुभिङ पोइन्ट O, यो मुभिङ पोइन्टले बनाएको path, the path that is traced by this point O is the locus of this point. Okay, we are going to find the locus of this point. That means we will be finding the equation of this point, this path. यो path चाहिँ यस्तो हुँदो रहेछ. अब यो path के हो भनेर त अब मसँग यो युगेश कटवाल हो कि हैन, श्रेयस मुडबरी हो कि, I don't know the name. Okay, अब यो त नाम त हुँदैन, यसको त फिक्स्ड नाम त हुँदैन. So what we are going to do is we need to find the equation of this point. Okay, let me see the path of the point P. Okay, the point that is at the circumference of the point. So let me see how the path is traced by the point P. Here, the path traced by this point is in this way. Okay, it will trace the path in this way. Actually, this is the locus of this point. यो point यसरी हिँड्दाखेरि जहाँ जहाँ पुग्छ नि यसको पाइलाहरू हो के. You can say in that way. Locus is actually the footsteps of the point. Okay, so यस्तो ट्रेस गर्दै त्यो सर्कल भित्र यसरी हिँड्यो भने. Okay, do you understand or not? So let me show the both points here. These 2 points will create a path like this. They have the different name or the different equation. The center is making a circle, and this point on the circumference is making some figure like cycloid. It is making some figure inside the circle. Okay, so actually this is the locus. It is the path traced by a moving point. These points are moving. The path traced by them is the locus. यो जुन path बनेको छ नि, it is locus. Okay, we will not find the name of the locus like Haribadur or something like that. We will find the equation of this locus. So let me continue to the slide. So let me show you one more example of locus there. I think it's not that important. Let me go to the next example. Okay, let's do this one also. So see here, this is a house and it has a door. Okay, if I go on stacking the doors in the same fashion, or if I go on rotating this door or opening this door, and I put door in every step that the door takes, then let's see how it goes. Okay, the door is opening and I am putting the door in each step the door takes. अब यो डोरले लिने सबै पोजिसनमा मैले यहाँ डोर राख्दै गए भने त, see here how it goes. It makes a part of a cylinder. Okay, this is also a locus. अघि हामीले पोइन्टको मात्र कुरा गरेका थियौ, यो त अलिकति 3 डाइमेन्सनमा भयो. though it is in 3 dimension, it will form a part of a cylinder. Okay, this is a locus actually. So let me show you one more thing. See here, suppose this is a coin. Okay, and I'm going to stack different level of coin over this coin. The same size of coin, if I go on stacking, एउटा कोइन छ, त्यो कोइनमा एउटा एउटा स्ट्याक गर्दै गयो भने त it will be a cylinder, isn't it? It is the path followed by this moving coin. Okay, so this coin, if we go on stacking, or if we move this point and put coin in its step that this coin takes, then it will form a cylinder here. Okay, so this is also the locus. So though this is in 3 dimension, these 2 example I have shown, this is of 3 dimension. Let me show you one more example how what it has to offer here. I think these are the almost all examples. So let me explain few more example in 2 dimension. Let me show you one more example. Please try to understand what actually locus is. Okay, locus is nothing but it is just the path traced by a moving point. We are not going to find the actual path. We are not going to make highway here. We are not going to make certain roads here. Okay, but the equation of locus we will be trying to find here. See, this is point A. I am fixing this point A. Let us suppose this is point. This is a certain pole. Okay, so this is point P. This is point P, and this point will be moving here. Let me fix the distance as 3. Okay, let me fix the distance between A and P as 3. अब यो A भन्नेमा एउटा पोलमा P भन्ने सपोज एउटा कुनै एउटा यहाँ एउटा जनावरलाई बाँधेको छ हैन. So let's move this point in such a way that its distance from this point is always 3. यो point यसरी हिँडायो भने त के हुन्छ होला, let's see. Okay, see here, the distance between A and P is 3 here also. The distance between them is 3 again here. The distance between them is again 3, again 3, again 3. If I go on maintaining the same distance throughout this path, then let's see how it goes on tracing. Let me see how it goes on tracing. Okay, see, it is forming a part of circle, and if I complete it, then it will form a circle. Do you understand or not? This point, if any point P move in such a way that is distance from the certain fixed point, but in particular here it is the center of the circle. If this point P moves in such a way that its distance from A is fixed, then it forms a circle. यसरी हेर्दा यसको लोकस त के बन्दो रहेछ, यसको पाथ त के बन्दो रहेछ भने सर्कल बन्दो रहेछ. Okay, the locus of P, the locus of this point P is circle with center at A and radius 3 unit. Do you understand or not? So locus के बन्यो यसमा चाहिँ a circle whose radius is 3 units. Okay, so if I go on increasing the radius here, it will be a bigger circle here. So let me make a circle of smaller radius than this one. So let me make the circle of radius 2.5. Okay, so let me move the point P so that its distance from point A is always 2.5. So it will be something like this. It will be a smaller circle than earlier one. If I make it 3, then it will be a circle of radius 3. Okay, भनेपछि कुनै एउटा फिक्स्ड पोइन्टबाट एउटा मुभिङ पोइन्ट हिँड्छ भने such that its distance is same, then it is a circle. So let me show you one more example. Okay, we will be discussing such example. We will be discussing the example in 2 dimensions here. So let's see the examples in 2 dimensions. Let's move this point P so that its distance from A and B is same. Okay, suppose A is your school and B is your home and P is you. Okay, maybe some Prozina or something like that. I don't know. Prozina, student with them, Prozina is here or not? I don't know. So let me move this P, this Prozina will move so that the distance from A and B will be same always. Okay, यसरी हिँडिरहेको छ कि यो A देखि B सम्मको डिस्टेन्स पनि 3.7, यहाँ पनि 3.7 भयो. अब अर्को ठाउँमा जाँदा त डिस्टेन्स अर्कै हुन्छ, but it must be equal. It must be equidistant from A and B. So let's see how it goes on. So if I move it, its path will be something like this. Okay, 3 भयो अलि माथि जाँदा 3.1 3.2 3.4 3.5 3.9 okay 3.4.6 something like this here. If it goes on like this, if any point move in such a way that its distance from 2 points is fixed, then it will form a straight line. एउटा पोइन्टबाट फिक्स भएर हिँड्दा चाहिँ अघि के बनेको थियो, सर्कल बनेको थियो. I'll try to find the equation later. But if the point is moving in such a way that its distance from A and B is always fixed or is always same, then it will form a straight line. Do you understand or not? के रहेछ भने कुनै दुईटा पोइन्टबाट डिस्टेन्स एउटै मेन्टेन गरेर गयो भने चाहिँ यसको जुन फुट स्टेप छ नि, यो प्रजिना हिँड्दाखेरि जुन यो फुटको स्टेपहरू बनिरहेछ नि, यसले के बनाइरहेछ, एउटा स्ट्रेट लाइन बनाइरहेछ भनेको. Do you understand? So we will find the equation of this straight line in this particular topic here. Let me show you one more example. I'm exposing you to the different variations of this topic here. So please try to understand what actually locus is. Locus भनेको के रहेछ, just try to understand. I'm giving you different examples here. So there are two paths, two straight lines. One of the point in the first straight line is E, and the next point on another straight line is F. So let me move this point P so that its distance from these two parallel lines is always fixed. Okay, यो point P लाई यसरी मुभ गराउँ so that यसको distance E र F को बीच अथवा यो दुईटा parallel line को बीचमा जुन छ यो जहिले पनि सेम होस्. Okay, how it goes on, let's see. So again it is a straight line. भनेपछि दुईटा पोइन्टबाट फिक्स डिस्टेन्स बनाएर जाँदा पनि स्ट्रेट लाइन बन्दो रहेछ. दुईटा प्यारलल लाइनसँग इक्वल डिस्टेन्स बनाएर जाँदा पनि के बन्दो रहेछ, स्ट्रेट लाइन नै बन्दो रहेछ. Okay, this is also a straight line. So I hope you understand. We have discussed three different examples. One in which the point was moving, in which the moving point was maintaining the fixed distance from a fixed point, or the distance was always same from the fixed point in the first example. In the second example, we discussed the locus of a moving point in which the point moves in such a way that its distance from the 2 points is same always. Here we are discussing such example in which the point is moving so that its distance from the two parallel lines is always fixed. It's 2.6, 2.6, 2.6 always. It is tracing a path that is a straight line. So दुईटा लाइनसँग स्ट्रेट लाइनबाट डिस्टेन्स सेम मेन्टेन गरेर गयो भने के बन्दो रहेछ, स्ट्रेट लाइन बन्दो रहेछ. इट मिन्स अब तिमीले के बुझ्नु पर्यो भने अब यस्तो इक्वेसन निकाल्यो भने त्यो इक्वेसनको डिग्री 1 हुनु पर्यो के. Okay, because the degree 1 equation is always the straight line. So let me show you one more example. Okay, so this is one straight line. Okay, and I am going to move this point P. I'm going to move this point P so that its distance from this straight line is E. Sorry, distance is 3. Let me show you under how many conditions, how many path will be there. कतिवटा path बन्दो रहेछ यसरी हिँड्दाखेरि. Okay, suppose this is the river. Suppose this is a river, and यो रिभरबाट 3 युनिट डिस्टेन्स मेन्टेन गरेर तिमी हिँड्नु पर्यो भने चाहिँ कस्तो पाथ भन्छ त, लेट्स सी. Okay, so if I go on moving this point, again it will be a straight line. स्ट्रेट लाइन बन्दो रहेछ. तर यो बाहेक अरू पनि केस छ त. सी हियर यो साइडबाट पनि जान मिल्छ नि त, रिभरको राइट साइडबाट पनि जान मिल्यो, रिभरको लेफ्ट साइडबाट पनि जान मिल्यो. So two straight lines, two conditions are possible. If there is a river and you are trying to move in such a way that the distance between the river and you is 3 units always, and you can go either from the right side or from the left side. So there will be two equations here. यस्तो केसमा चाहिँ दुईटा इक्वेसन हुने रहेछ. Okay, and one equation represents the equation on one side of the line, and the another equation or the another path represents the equation on the other side of the line. So let me be brief here. So let me go the one more example, that is the last example. So try to understand this one also. I think there is a question of based on this topic also, based on this particular type. So I'm going to move this point P so that these two intersecting lines here, there are two intersecting lines here. This point P will be moving so that its distance between these 2 points or these two straight lines is always same. यो दुईटा स्ट्रेट लाइन छ, यो दुईटा बाटो छ, तिमीलाई अब यसरी हिँड्नु पर्यो. I have certain geometrical condition for you or certain mathematical condition for you that You need to move in such a way that you maintain a fixed distance. You maintain a same distance or the equal distance between these two straight lines. You move in such a way that your distance from these two paths will be always same. So here 1.8 from E, 1.8 from E. So let me move a bit further. 2 from this point, E, distance 2 from this point again. So if I move it so that again it is a straight line. Is there other way possible also? So let's see. There is another possibility also. यो केसमा त यसरी पनि हिँड्न सक्दो रहेछ दुईटा इन्टरसेक्टिङ लाइन छ भने पनि in this case also we have two straight lines or we need to find two straight lines, two equation of the path. Okay, so these are all the examples of the locus that I have to explain you. So let me go to the real example. अब यो त अब हामीले geometrical illustration गर्यो. These are the just the illustration of what actually locus is. So now I am going to solve the equation of locus. To find the equation of locus, let's go. So this is the step. So write it, please. Note. I hope you have written the definition in the earlier slide. So write this different points. These 2 points. Note every point in the locus. When you get the path here, okay. Every point in the locus. Points in the locus must satisfy. Every point in the locus must satisfy the given geometrical condition. Okay, locus मा भएको सबै पोइन्टले चाहिँ के गर्नु पर्यो geometrical condition लाई satisfy गर्नु पर्यो. I will show you what actually this means. यसले भनेको के हो भन्ने कुरा चाहिँ म बुझाउँछु. If a point satisfies, यसलाई उल्टो गरेर लेखौं. If a point satisfies the given geometrical condition, then it lies on the locus. Write it fast so that I can explain it. Just a moment, I'll share the PowerPoint slide only. Okay, write it fast. Have you copied it? Please let me know if you have not copied. I'm going to go to the next slide. Please write it fast. Okay, let me name some students here. Smriti Dhakal is present here. Smriti Dhakal, can you turn on your microphone? I think you have not given online examination. Tomorrow there will be online examination at 2 p.m. Please be present there. Smriti Dhakal, are you listening me? I'll create a separate group for those students who has not taken examination. Smriti, are you listening me? Smriti Dhakal, I think you are present here and you are not responding. Please respond here.
Sir, नदिएकोले दिने हो.
हैन दिएकोले पर्दैन नदिएकोले मात्रै. Okay, Sabina Bandari. Sabina Bandari, are you present? Yeah, Sabina, are you listening me?
Yes, sir.
Okay, tomorrow there will be the examination at 2 p.m. Okay.
Okay, sir.
Yukti Sharma. Yukti Sharma, is she here? Please write it. Okay, this slide. Please continue writing this slide. Okay, I'll display one more slide also so that you can go on writing. Just write this. I'll explain it later. Okay. Write this. I'll be taking the. I'll be interacting with few students here. Okay, Ashish Ale. Is Ashish here? Ashish Ale, are you here or not? Please just copy this question. Okay, copy the question in the solution. I'll explain it later. Ashish Ale, let me see whether he's here or not. Okay, Ashish is not here. I need to call him. Yukti Sharma. Avian Podel. He is also not here. Pratik Koirala, are you here? Pratik Koirala. Pratik, can you respond me? Pratik, please turn on your microphone and speak. It's not about asking question. Please turn on your microphone. I'm going to interact with you. Pratik, turn on your microphone, please. Okay, Pratik, you are raising your hand. Please let me know that you will be attending the examination tomorrow at 2 p.m. or not. Please type it in chat box or just respond me here. You need to give your examination. Otherwise, you may not get admitted to school, or there will be some difficulties for you. Okay. This all classes will be counted as the your physical presence class, because when you give the final examination of your classes, uh, the credit hour will be counted, and this class also will be counted as the credit hours. So Pratik Koirala, you will be attending the examination at 2 p.m. So I am marking your name. Roman Shrest, is here Roman Shrest? Let me see. Roman Shrest, can you respond me, Roman? Roman Shrest, please turn on your microphone and speak with me. Roman, I know you are here. Please respond me either in chat group or you can say. Okay, Pratik Koirala, you have. I have already attended. My mic is not working. So Pratik Koirala, let me see. Pratik Koirala. Pratik, have you submitted from others' name? From other students' name, from other class? Please write in the chat group there. घरमा 2-3 जना अरू भयो भने अरूको मोबाइलबाट त्यसरी दियो कि I haven't got your response in your chat group or in the online examination form. My mic is not working. No, sir. You haven't given for other name also. There is no other students. Let me see. Let me check it once. Okay. Others, please copy that. Okay. I will interact individually later. I think there will be disturbance for others. I'll call you individually later after around 10 to 11 p.m. I'll conduct call today, and tomorrow there will be examination. Let me check, Pratik. I will see whether you have given examination or not. If have you got the thank you message at last or not, Pratik? If you have submitted, then there should be the thank you message. You must have got a thank you message at last. Your the message like your form is submitted or something like that. Pratik, please write it there. If you are facing problem with the microphone, please write it there. Okay, I'm going to see your response here. Though I have seen it earlier also. Pratik. Pratik, your name is not here. I'll confirm it later, and I'll call you if you have not given an examination. Okay, I'll call later. So let me continue the slide. Let's not disturb the regular class. So let me begin from earlier one. Okay, every point in the locus must satisfy the given geometrical conditions. Okay, suppose here, suppose this is the path traced by a moving point. Suppose this is a straight line. Okay, suppose this is a straight line. In this straight line, there are infinite number of points. एकदम धेरै पोइन्टहरु कम्बाइन भएर एउटा स्ट्रेट लाइन बनायो नि हैन. After connecting a lot of dots here, this has formed the straight line. जस्तो तिमीले चाहिँ पोते बुन्नु पर्यो भने चाहिँ त्यो सानसानो पोतेको दानाहरु जोड्यो भने एउटा लामो पोते भन्छ नि. But in fact, you have joined a lot of potes there, हैन? के भन्छ पोतेलाई? So this point, this particular point is in this straight line, is in the equation of this straight line. अब यो स्ट्रेट लाइनमा छ भने यसको इक्वेसन हो. लेट मी सपोज दिस इक्वेसन इज 3x + 2y = 0. ओके, सपोज दिस इक्वेसन इज 3x + 2y = 0. मैले अघि नाम भनेको थिएँ नि, स्ट्रेट लाइनको नाम निकाल्ने, स्ट्रेट लाइनको इक्वेसन निकाल्ने भने कि यसको नाम निकाल्ने जस्तै हो के. एन्ड दिस विल बी सेम थ्रु आउट द वर्ल्ड. एज आई टोल्ड यु अर्लियर, दिस विल बी सेम थ्रु आउट इन इट विल बी सेम इन अमेरिका अल्सो, एन्ड इट विल बी सेम इन नेपाल अल्सो. सो लेट मी चेक one point, if this point lies on this equation or not. Let us check whether 0, 0 lies in this point or not. There are infinite number of points. We don't know what are the different coordinates, whether that may be fraction points or anything, negative, positive, any coordinates may be that. So if this point lies on the locus, यदि यो straight line मा पर्छ भने, every point on the locus, I'm saying that this point lies on the locus. मैले के भनिरहेको छु, यो point चाहिँ यो इक्वेसनमा पर्छ भनिरहेको छु. If this point lies on the locus, it must satisfy the given geometrical condition. हैन point पर्छ भने the point lies on the locus, point lies on locus, then it satisfy the condition. अब satisfy भने के हो अब यो हैन what does it mean by satisfying the given geometrical condition? Let me check. If the point satisfy the given geometrical condition, then it means that when you replace the value of x and y on this equation, the LHS and the RHS of the equation will be same. बुझ्यो बुझेन satisfy भने के छ भने यो point को भ्यालुहरु यसमा राख्दाखेरि यो कोअर्डिनेट को भ्यालु यसमा राख्दाखेरि यसको लेफ्ट ह्यान्ड साइड र राइट ह्यान्ड साइड इक्वल हुनु पर्यो भनेको. लेट मी सी whether it is satisfying or not. 3x plus 2y is equal to 0. This is the equation. If you put 0 and 0, the value of x is 0. 3 times 0 plus 2 times 0 is equals to 0. So 0 is equals to 0. The left hand side is equals to right hand side. So satisfy भनेको के रहेछ भने it means LHS must be equals to RHS when you put the value of x and y in the equation. Please remember it. This is very important. You need to understand it. You need to understand it and remember it also. So if a point lies on the locus, then it must satisfy the equation. The second statement is just opposite of it, just the converse of it. So if the point satisfies the equation, then it lies on the locus. यदि कुनै point ले equation लाई satisfy गर्छ भने त्यो के भन्न सकिन्छ point चाहिँ locus मा पर्छ भने. यसलाई यसरी बुझौँ न. सब नेपाली हो भने तिम्रो चाहिँ आइडेन्टिफिकेसन के हुन्छ नेपाली हो भन्नको लागि त अब नेपाली बोल्नु पर्यो अथवा नेपालमा मान्छेको जस्तो बिहेभियर हुन्छ त्यस्तै खालको बिहेभियर त्यस्तो खालको कस्टम्स हैन तिमीले त्यहाँको जानेको हुनु पर्यो आइडेन्टिफिकेसनको लागि. सपोज एउटा नदी हो भन्नको लागि के हुनु पर्यो त्यसमा पानी हुनु पर्यो नि हैन. नदी भनेको छ त्यहाँ केही पनि छैन बगर छ भने चाहिँ हामीले नदी त भन्न सकिएन. ओके यो नदीको यो कुनै एउटा पोइन्टले पानीले चाहिँ अब त्यसकै नदीकै पानी हो भन्नको लागि त अब त्यसको सर्टेन पर्टिकुलर टेस्ट हुन्छ होला सर्टेन पर्टिकुलर कलर हुन्छ होला हैन. पानीको त के टेस्ट र कलर भन्नु बट सर्टेन एउटा प्लेसमा भएको पोइन्टलाई पानीलाई चाहिँ चेक गरे जस्तो नदीको पानी हो कि हैन भने जस्तो के गंगा जल ल्याउँछ नि हैन गंगाको जल हो कि हैन भनेर कसरी चेक गर्ने त्यसलाई. इट्स समथिङ लाइक दैट. यो स्ट्रेट लाइनको यो पोइन्ट हो कि हैन भनेर चेक गर्नका लागि के गर्नु पर्यो इट मस्ट satisfy the equation. Satisfy भने के रहेछ point द इक्वेसनमा राख्दा यसले LHS इक्वल्स टु RHS हुन्छ. यसको जस्ट अपोजिट के भन्यो हैन ओहो यो पानी त यसो हेर्दा त गंगा जल जस्तो छ भनेर भने के हैन. इफ इट satisfy the given condition, then the point lies on the locus. Let me see. अब यो just धेरै explanation भयो. Let me show you some examples also. Does the point 2, 3 lie on the locus x square plus y square is equals to 13? Okay, x square plus y square is equals to 13 भने चाहिँ यस्तो कर्व हुन्छ. I'll show you. Just a minute. Let me display it in the full desktop. Let me share here the full desktop. So here x square plus y square is equals to 13. Though you don't need to know all these things. तिमीलाई यो सबै कुरा जान्न अहिले जरुरी छैन. तर बुझ्यो भने चाहिँ एकदम त्यो लोकस बुझ्नको लागि इट विल बी भेरी इजियर. ओके सो x square plus y square is equals to 13 भने कस्तो जन्तु हो त लेट्स सी. Okay, here this x square plus y square is equals to 13 भने चाहिँ यस्तो पोइन्ट हो कि हेर त यो x square plus y square is equals to 13 छ भने यस्तो यो सर्कल बन्द रहेछ. तिमीले सबै पोइन्टहरु लियो भने यसलाई यसरी ट्रेस गर्यो भने नि बाटो बनायो भने नि यसले बनाउने के रहेछ एउटा सर्कल रहेछ. अब लेट्स सी the question is asking you the point 2, 3. Let me see 2, 3 whether this point lies on the locus or not. 2, 3. So see here 2, 3 if this point is lying in this locus यो पोइन्ट यसमा परिरहेछ नि हेर त यसको पासमै पर्यो नि. अब यो त जियोमेट्रिकली भयो. let us do it mathematically. Okay, let us do it whether this point satisfies the given condition or not. Okay, मैले अघि भनेको कुरा यहाँ ट्रू छ कि छैन. लेट्स show it. Okay, let's do it. So let me write it here. Solution here. I hope you have copied it. X square plus y square is equals to 13. This is the given equation. Putting the point 2, 3, that is x equals to 2 and y equals to 3 in the given equation, we get, and putting the value of x here, that is 2 square plus 3 square equals to 13. So 4 plus 9 equals to 13. Therefore 13 equals to 13. This is true. Okay, if this is true, you satisfy by any left hand side is equals to right hand side. So this is true. If it was false, if barabar aayana bhane you need to write here false. Okay, hence the point 2, 3 lies in the equation of the locus x square plus y square is equals to 13. यसरी बुझ्ने क्या लागि अघि मैले के देखाएँ फिगरबाट देखाएँ नि यो पाथमा यसरी यो पर्छ कि पर्दैन भनेर फिगरमा देखाएँ and to do it mathematically what you need to do is you need to point the point, you need to put the value of x and the value of y in the equation, and if the value of left hand side and the right hand side is equal, then you can conclude that this point lies on the equation or the in the locus of the moving point. So let me display the PowerPoint only. I'm sorry for the disturbance. So please copy it first. If you have not copied, please let me know. Please let me know if you have copied or not. So let's go to the next slide. Please let me know if you have not copied. Okay. Find the value of k if the point 4, 3 lies on the locus. Okay. Point चाहिँ त्यो लोकसमा पर्छ अरे. Find the value of k. The question is asking you to find the value of k. Okay. So what do you need to do there? Just for a few moments. Just wait for a few moments. Okay, let me explain it. Okay, this question is find the value of k if the point 4, 3 lies in the locus x square plus y square plus kx plus 3y minus 16 equals to 0. This is a locus. Your equation दिएको छ. यो equation को maybe it may be a straight line or it may be some certain curve. Okay, it may be certain circle or something like that. We don't know whether it is which geometrical shape it takes, but we know the equation of it. हामीलाई के थाहा छ यसको इक्वेसन थाहा छ x square plus y square plus kx plus 3y minus 16 equals to 0. The question is clearly saying that this point 4, 3 lies on it. If this point 4, 3 lies on this line, then it must satisfy. मैले अघि भनेको थिएँ नि point locusमा पर्छ भने it must satisfy. Okay, so let's use that concept to find the value of k. Okay, do you understand or not? Please let me know if you didn't understand. So please copy this. The given equation of the locus is x square plus y square plus ky plus 3y minus 16 equals to 0. This is the given equation of the locus. The point 4, 3 lies in the locus. This is given by the equation by the question. So let's put x equals to 4 and y equals to 3 in the above equation, so that it will be, so instead of x it will be 4 square plus 3 square plus k times 4 plus 3 times 3 minus 16 equals to 0. Simplify it and you will get the value of k is minus 9 by 2. Please let me know if you have any problem. Please copy it first. Okay. And let me know if you
Okay, have you copied it? Please let me know. Can anyone let me know? Have you copied it or not? Have you finished it? Please let me know.
please interact with me. Neeraj, have you copied it? Neeraj Sharma, have you copied it? Neeraj Sharma.
Yes, sir.
Okay, that's good. So let's go to the next one. Just few moments. Okay, Rupesh Adhikari, Yogesh Katwal, yeah, they are raising hand. It means they have completed. So let's go to the next question. If the point 2, 3 lies in the locus, whose equation is 5x plus by is equals to 16, so that 0, 8 also lies in the locus. Question K1. Let's try to understand. Here, please write the question. There is the equation 5x plus by is equals to 16. We don't know the value of b here. This is a constant. 5x plus by is equals to 16. And the question is saying that this point 2, 3 lies on the locus, or this point lies on the equation of this equation. So you need to show that this point 0, 8 also lies on this locus. So this is the combination of two questions. Okay. At first you need to show that this point lies in this locus. This point. The question is asserting that this point 2, 3 lies on this equation. And secondly, what you need to do is you need to prove that this point lies on the locus. At first, it is saying that, it is asserting that, it is giving us that this point 2, 3 lies on this locus. So let's use this condition to find the value of b. यस्तो constant छ भने हामीले प्रुभ गर्न गाह्रो हुन्छ. Okay. So at first, what you need to do, you need to use the first point 2, 3 to find the value of b. So let's do it. Here 5x plus by is equals to 16. This is the given equation. Point 2, 3 lies in the locus. Write along with me, please. The point 2, 3, this point is lying in the locus. So what it needs to do? It needs to satisfy this equation. Please don't forget to mute your microphone whenever you join it. I don't know who joined it just now. Okay, so if this point 2, 3 lies on the locus, lies in the equation 5x plus by is equals to 16, let's put the point 2, 3 lies in the locus. So putting, write this one also, putting x equals to 2 and y equals to 3 in equation 1. 5 times 2 plus b times 3 is equals to 16. So this is 3b is equals to 16 minus 5 to the 10. 16 minus 10. 3b is equals to 6. B is equals to 2. So we got the value of b. Our first part is done. Though this question is not asking to find the value of b, we need to find the value of b to show that this also lies here. Okay. So you need to be aware with the question. You need to understand what question is actually trying to say. 2, 3 यसमा पर्छ भनेको दिएको छ त्यसबाट b निकाल्ने. Okay. The b निकालिसकेपछि बल्ल यो सेकेन्ड पार्टमा जाने. Copy it up here so that I can go to the second part. Up to here the locus is given already. है हामीले यहाँसम्म अहिलेसम्म locus दिएकै छ. But in few other slides we will be finding the actual locus. हामीले त्यो locus नै निकाल्ने छौं त्यहाँनिर है त. So put the value of b in the given equation. In equation 1, we get 5x plus 2y is equals to 16. If b यसमा राख्यो भने first equation राख्यो भने के हुन्छ? The equation will be 5x plus 2y equals to 16. I am putting this value of b here, okay? So it will be 5x plus 2y is equals to 16. So the second part, so that the point 0, 8 lies in the locus. Let's show it. Putting 0, 8 in the locus, this locus, we get, or you can say that again putting 0, 8 in the equation. Putting 0, 8 in the equation, you can write in this way also. In the equation, 5x plus 2y is equals to 16. Locus भनेको equation हो. So 5x plus 2y is equals to 16 मा राख्यो भने what it will be? It will be 5 times 0 plus 2 times 8 equals to 16. So 16 equals to 16. This is true. If this is true, then we can assert that we can say that the point 0, 8 also lies in the locus. I hope you understand this. So please copy it first and we'll go to the next one. Reason, have you given examination or not? Reason? Okay, let me read out few names here. Those students, I haven't got the response in the form. I don't know, there may be some other names also, but I have listed the few names here. Hansel Shrestha, David Sahi, Nishan Gale, Tiru Sahi, Prasant Gurung, Ashish Chaudhary, Trishana Gurung, Sri Malla, Ayush Gurung, Suhana Kapali, and then Nitesh Saha, Sujal Shrestha, Subhas Baral, Pasvina Rizal, Rajina Shrestha, Jyotsna Gurung. These are the few names. Sabina Bandari, Yupti Sharma, Ashish Ale, Abhiyan Podel, and Smriti Dakal, Umang Shrestha also. So these are the few names that I need to take right now. If I haven't got your response, I may call you later. Okay. If you are online in Teams, then I will call on Teams. And if you are not online in Teams, then I may call in your phone number that is provided in the Teams. I may call your guardian. Okay. If you have taken the online examination and even I am taking your name also, please let me know. You don't need to give the online examination if you have already given it. So this is all about this question. Let's go to the next question. Do the points 3, 2, 4, 3, 5, 0, 0, -5, -3, -4 lie on the locus? The equation is x square plus y square is equal to 25. The question is giving you multiple points here. Okay, and it's asking you to check whether the points lies on this locus or not. So this will be the last question for today. So let's check. Let's do it. Please try to do it yourself. Okay, I'll do one for you. Remaining points you will do it yourself. Here, x square plus y square is equals to 25. This is the given equation. So let's take every point for 3, 2. Putting x equals to 3 and y equals to 2 in equation 1. It will be 3 square plus 2 square equals to 25. Simplify it. 9 plus 4 is equals to 25. 13 is equals to 25. This is false. Okay. So if it is false, then this point does not lie on the locus. Therefore, 3, 2 does not lie on the locus. The locus of the equation. Locus of the equation x square plus y square equals to 25. Please go on checking for other points. Do it yourself and let me know whether these points lie on this locus or not. दुईटा कुरा जाने आज एउटा लोकस डिफाइन गर्न जाने होला डिफाइन जाने त्यो याद छैन भनेपछि याद गर्ने इज समथिङ इज द पाथ ट्रेस्ड बाइ अ मुभिङ पोइन्टले बनाएको पाथ नै हो एन्ड द नेक्स्ट थिङ दैट यू लर्न टुडे इज इफ a point lies on the locus then it satisfies the equation. Point locus ma parcha bhane equation satisfy garcha. Second thing that you learned here is if the point satisfies the equation of the locus then it lies on the locus. कुनै एउटा पोइन्टले इक्वेसन सेटिस्फाई गर्छ भने लोकसमा पर्छ. यो दुईटा कुरा चाहिँ आज जाने. So please take these other points also. लोकस भनेको एउटा लामो पाथ हो नि त हैन. ठुलो एउटा यस्तो पाथ बाटो हुन्छ. अब यो बाटोमा धेरै पोइन्टहरु हुन्छ. यो धेरै पोइन्ट मध्ये यो 3-4 पोइन्ट जुन दिएको छ यो हो कि हैन चेक गर भनेको क्वेशनले. It's not always necessary that it must be a circle. It may be straight line. यसको पनि हुन सक्छ. यहाँ भएको पोइन्टहरु पनि हुन सक्छ. Okay. Just so check it please. 4 comma 3, does it lie in this locus or not? Please let me know if you have solved it. Someone, are you listening me? Someone, are you turning on your microphone or not? Someone, are you listening me or not? Please let me know if you have solved it, whether this point lie on the locus or not. Please tell me. Okay, Nitesh Saha, I haven't given online examination. Okay, I'll take your online examination tomorrow, so please have to present there at 2 p.m. You can turn on your Teams maybe around 1:50. I'll be joining the Teams before 2 p.m. maybe around 1:30 or 1:45, and I'll include all the students who have not given online examination. Nitesh Saha. And other few other students who has informed me in the Teams chat group. I may not contact them personally as they have already responded. And if you have not responded, then I'll call your guardian to take the online, or making you to take the online examination. Okay, please do all the check all the points. Please check all the points. Can anyone tell me, has this point satisfied 4-3? Just this point 4-3. It is. Have you checked for this point 4-3? It is. Have you checked the point? Okay, someone not, I don't know. You have a lot of disturbance in
Yes,
background.
sir.
With this point 4,3 satisfies or not? Someone else.
2,3, yes, sir. True.
4,3 satisfies. 5,0.
5,0 गरिदियो, sir.
Yes. Okay. Please go on solving all the questions. Okay. All the points. Go on checking all the points, and make sure that you solve all these questions. Okay, for all these points. So thank you everyone. I think there is another class also. Now you can leave this session, and please try to revise all these things. Okay, and just see your exercise book also. See your textbook also. There are a lot of problems like that we discussed today. So please go through your textbook and see there. If you find any problem related to this exercise, please let me know. Revise these things, and that's all for today. Bye bye. Take care. Have a great day. Now you can join the other class also. Let me end this. Thank you. Have a great day.